Rational exponents. Remember, we're talking about rational exponents. We're talking about nth roots. Remember, your rational numbers are going to be the ones you can write as fractions. In this case here, we're talking about what's called a fourth root. And we've kind of discussed a little bit of this in the past. We've talked about how this stuff plays, how this stuff looks. When you take a square root, you're asking yourself, what times what equals that number underneath the radical? That's a square root. You're getting two numbers. In this case here, I'm asking what are four numbers you would multiply together that are the same number to get 81? 3. 3 times 3 times 3 times 3. Or, say it, you want to. Negative 3. What's negative 3 times negative 3?
9.
Times negative 3.
Negative.
Times negative 3. 81. What happens here is that what this is saying is what are four numbers that are the same to multiply to equal 81. This is called a fourth root. What are four numbers you multiply together to get 81? That's what that means. Since this nth root, if you will, is an even number, now we'll get to that here in a second. That's basically 3 times 3 times 3 times 3. Or negative 3, negative 3. So the fourth root of 81 would be plus or minus 3. All right. Now there are different rules for what's going on. One of the things that we're going to work on today is writing these nth roots. We're going to write them as rational exponents. Then we're going to write rational exponents as nth roots. Goes either direction. There will be some of these that you'll be able to figure out relatively easily in your head because the numbers really aren't that scary, which means that we will be calculator, non-calculator again. All right. So let's take a look at what's going on here. When you're writing out these nth root stuff, there are some generic rules to look at. And there's a lot of words here for something that's very, very simplistic. If you look at what we just did with the fourth root of 81, the nth root here, that value, that fourth root, is 4 even or odd? Even. It's even. Okay. The value of a, is it positive or negative? Positive. So if I take a fourth root of a positive number, what happens here is since that root, that 4, is even, your answer is always going to be plus or minus whenever this value is even and when this is positive. Because it makes sense, because that means we take a square, when you take a square root of 9, it's plus or minus 3. Take the square root of 25, it's plus or minus 5. If I take the fourth root of something, it's still an even power. If I take the sixth root, I take the 12th root, whatever. If it's an even nth root, you're always going to have plus minus. If it's an odd value, if it's the cube root, well, this was 3. Let's say it's the cube root of 8. That's something we all know, right? It's 2. Now, what's the cube root of negative 8? It's negative 2. I can take a cube root of a negative value because it's asking me, in this case, what are 3 numbers that I multiply together that are the same to get me negative 8? Well, negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is? So in this case here, when I have an odd exponent, I don't have to do plus or minus. When I have an odd exponent, I don't have to do plus or minus because my odd exponents, if the a value is negative, it's going to work out just fine. If the a value is negative and it's an even root, I can't have any rational, or I wouldn't have any real answers here. I'd have imaginary stuff. Okay, so what we're talking about here is we're looking for real roots. That's what it needs to have, the real nth roots. Yes, sir?
Wait, will it ever figure out imaginary things?
I don't think it really comes up all that often in this chapter. There's towards it into 7.6, when we solve some equations, it'll show up a little bit, but this first few sections are really not going to do that.
So you'll never have like a n root positive with like value negative?
No, I don't think you can see it. What you might see is when we get into just 1 second, when we get into 7.6, you'll have stuff like this where you're solving equations. I don't know, whatever, 3, I don't know what it could be. You're solving equations like this and you're looking for those values. You could have an imaginary solution because you'll have to factor at the end. But when you're doing these things, you don't have to really worry about it. Right. Yes, sir?
Will there be the fractions?
Yeah. Yeah. Oh yeah. We'll get to it. We'll get to it. Oh yeah. Because you remember all those exponent rules we had in 6? All those still apply with the rational exponents, fractions. They all work out just the same. What I wanted to show it to you though is how this stuff works. Going from nth root to the fractional exponent, and how to go from fractional exponent to nth root. It's a very simplistic way to write things out. When we have the 4th root of 81, that could be written like this. Let me just move this out of the way for right now, come back to it. The 4th root of 81, well, this is my a value, so that's 81. The root, that number next to the radical, always goes in the denominator of a fractional exponent. So 81 to the 1/4 is the same exact thing as the 4th root of 81. Those are synonymous with one another. They mean the same thing. What's happening here is you have the n root of some number always equals a to 1/n. That's kind of the generic rule here. So when it asks you to write things from nth root to rational, that's nth root. If I wanted to write that as a rational, it would be 32 to the 1/5. What's the 5th root of 32? No. What are 5 numbers that you multiply together that are the same to get 32? It's 2. These are some of the things you'll start to pick up on. Now what's going to happen here is that they're going to ask you to do the following. Oh, I never pressed record. I'm sorry. Oh, I did. They're going to ask you to do the following. Find the nth root. Again, in this case here, they'll give you a value of n, a value of a, and you write it out. What's the cube root of negative 125? What are 3 numbers that you multiply together that are the same numbers to get you negative 125? Negative 5. Good. Okay. What are 4 numbers you multiply together that gets you 16? Plus or minus 2, very good. Really not that scary, is it? No. Not yet. I get there. Because then we get to the fractional ones.
Oh.
And what you want to remember here is the following. Is that anything to a fractional exponent, if it's got a fractional exponent, that denominator of the fraction is always the nth root. And it's always raised to the m power. What's that? Okay. That's how that works. Now, as you walk through the examples then, in this first one, my a value is 9. My n value, my nth root is 2. A 2 root means what? Square root. So this is nothing more than the square root of 9 cubed. What would you do with order of operations then? All right, what do I do in parentheses? Now, when you're doing these, when you're working with just the rational ones, you just take the square root of 9 and it's just going to be 3. Okay. Then you cube it. What do you get? 27. The difference between simplifying out one of these and where did I have it? What is the fourth root of that? It's just fourth root. There's no other n value, if you will. It's just the n. You're looking for the nth root. You're not working with the actual mixed number, if you want to call that. All right. Same idea here. This is a negative exponent. Is that happy where it is? It's not happy. So send it where it's happy. Oops. Now it's happy. Which means you can use the rule again. This is the same thing as saying 1 over, well, what's my nth root here? 5. What's the fifth root of 32 squared? 4. The fifth root of 32 is 2. 2 squared is 4. So your answer is 1/4. Okay, you get 1/4 on that. This one is just written differently. But could you still figure it out?
Yeah.
Okay. This one is, well, what's the cube root of -8?
Negative 2?
Is it 2 or -2?
Negative 2.
-2. Now, what's -2 to the 5th power? -32. And was that okay to keep that wall with the negative values? Oh yeah. Negative values are all going to hold here because you've got odd n value. No, if this was like the fourth root of -8, it's going to be looking for real answers. So you just wouldn't have to do it. There'd be no solution. Stuff like that. Because it's asking for a real, not an imaginary. Now, how could you rewrite this one, the cube root of -8 to the 5th power? How would you rewrite that in rational exponents? Yes, sir.
-8 to the 3/5.
So is it 3/5 or 5/3? 5/3. Yeah, the n value always goes to the denominator. Always, always, always goes to the denominator. Okay? N. The n value always goes to the denominator. Yeah, we're not going to do that.
Why does it, like, for the examples, they write it instead of like a 3/2, it's like 3
Slash?
slash 2.
I don't know. Saving space, maybe? Yeah. See, just how the typeset was. But what this is now going to allow us to be able to do is solve scary, scary equations. Dun, dun, dun. Now, if I'm going to solve a scary equation, 2x to the 4th equals 162. What do you think the first thing is you have to do? Divide by 2. Good. So if I divide by 2, I get x to the 4th is 81. How do you undo a 4th root? Excuse me, how do you undo the 4th power? You 4th root it. Okay? Here's why that works. When you are unfourthing, if you will, on this one, what you're doing here is you've got x to the fourth over 4. If you rewrite it using the rational exponents, which gives you x to the first power. So your x value is going to equal the fourth root of 81. Now, I did a fourth root over an equal sign. The n value is an even number. Should I worry about plus minus or no?
Yes.
Worry about plus minus. What's the fourth root of 81? Okay. What's that? Enough so that way you recognize it. So, what do you do on the other one now? What's that? Cube it or cube root it? Cube root it. Good. I'm going to cube root it. All right. The cube root of junk cubed is junk. Do we know what the cube root of 10 is? Oh, it is. Can I leave it like that? Can I simplify that? Is there any perfect cube that goes into 10? Do you remember what that means when I asked about perfect cube? I'm looking to see your perfect cube. 1, 8, 27, 1 cubed, 2 cubed, 3 cubed, 4 cubed, 64. None of those work into it, so I just leave it like that. And now what do I do with the negative 2? I add to the other side. Do you think it should go in front of that cube root or back of it? In front, yeah. So x is going to equal to 2 plus cube root of 10. Did I have to worry about plus minus here?
No.
Why?
Because it's
It is odd. The nth root there is odd. Yeah.
Can you write it as 10 to the third power?
No, that's not 10 to the third power, because what you had to do here is you take the cube root.
10 to the
Oh,
1/3.
10 to the third. I'm sorry. I know what you mean now.
1/3.
1/3 power. Yeah. Now you resaid that. Yes. If you wanted to write 10 to the 1/3, that's fine.
Okay.
That's fine. I have no problem with that. Yeah.
Was it wrong to put the 2
No, it's just more mathematically proper to do that. That's all. It just looks right. You always, whenever you're writing out your solution stuff, you always put your integers first, your real numbers, and you start getting to the nasty looking things towards the back end. That's why you put like i's in different spots, and the i's always go in front of radicals. Radicals are kind of like the forgotten child at the end. What? Well, I don't mean it like badly, but not regularly. I try not to.
You made it great, Dad.
I do. Thank you.
My dad left me at the library once.
My mom watched
Just
it.
go by
You were
down
just
my-
you were just too quiet. You didn't realize we were there.
I was just like
Good
sitting
library
outside,
joke?
I was like, where's my dad?
Bad.
Good thing I live close to the library.
It's a good thing. So he taught you resourcefulness.
And then I came home and I was like, Leah, Dad forgot me. And then he was cleaning the clothes, so Leah goes out and she's like, Dad, did you forget something? He's like, see, I'm with
That's awesome. Stories of parenting. Are you sure they need to?
My mom watched me walk.
Right.
And then they started calling my name like the singer. And then he laughed
You know, when I worked at when I was in management with Home Depot, we yeah. Crazy. It is a small world. We had that happen where a kid got separated with his parents. We had to lock everything down and not let people walk out. Yeah. It's,
In here?
yes, it was at the high school. Again. Notice I haven't mentioned to you guys yet that you can solve most of these, well, you can solve all of these with your calculator. Now, there are buttons that allow you to find nth roots. There are buttons that allow you to raise the exponents back and forth with the rational stuff. But I also want you to be able to crank these out by hand. Which means you have to use a little bit of the brain. Not a lot of it, just a little bit. For example, I think we have all seen the fourth root of 81 before today, right?
Yeah.
What's the fourth root of 81?
Plus or minus.
All right, just now. I know there is.
Why did you tell us
It doesn't do any good.
Where's the I button? I want it.
Yeah, it does actually.
Where do I want it?
What does the half power mean again? Square root. Yeah, the 2 root. Yeah, it's fine. It's fine. Now, what's the square root of 49? Now, with that negative out in front, what do you think it's looking for? Just looking for the -7. That's all it means. Okay? All right, number 6. We've seen it. What's the cube root of -8? -2. What's -2 to the 5th power? -32. Now this one's tricky. It's the 5th root of 3, 1, 2, 5. Just look at the numbers.
625.
The 5th root of 3,125. What do you think the number has to end in?
5.
A 5. Now that means it's going to be 5 or it could be 25. It could be,
5.
well, let's think about this. Just using brains, 25 times 25 is 625. If I multiply that again by 25, it's going to be bigger than 3,125. 5 to the 5th would not be 125. 5 to the 3rd is 125. So I'm guessing just by my powers of craziness.
It's under power of this problem.
No. The 5th root of 3,125, I bet, is 5. And what's 5 squared?
Plus or minus.
No, not in this
There has
case.
to be some way to like.
Because you're taking an odd root, so we don't have to worry about it. Okay? You're taking an odd root. Oh, what's that?
There has to be some way that you can do this.
This is as easy as this gets.
I mean, they do math all the time.
It's not that much, not really all that.
I know it's not that hard.
Yes.
I got one on here too. Never happened in proper fraction for that, right? 'Cause that would just be
What do you mean by improper fraction? For the nth root?
yeah,
fractional?
yeah, like -49 to the half. Never that. Never mind.
You can. I know you're going to. You can have 49 to the 3 halves if you want.
Yeah, that's fine.
You can do that. That's fine. Because that just means the square root of 49 cubed. So that would be 7 cubed, which is some number I don't know off the top of my head.
Will we have something like the test? Or no?
It would be something you'd be able to do.
Right. I just meant let's not.
If it was like 2 to the 3 halves, or 4 to the 3 halves would probably be something easier. Because 4 to the 3 halves would be the square root of 4, which is 2, and then 2 cubed is 8. So you could do that one, I would say. I would hope. All right. It'll be a lot easier. It'll be numbers that I want you to be able to do that you should be able to figure out in your head. I'm not going to give you something that's just going to be god-awful, horrible, horrible. Maybe. All right, we'll take a second to solve the equations now. Remember your rules for whether or not you have to have plus minus. Sometimes you. So again, on number 8, you don't need to have plus minus because it's an odd root. So your answer is
You got lost next. Boom.
9. What's your answer? -1. I agree. We get -1 there?
Yeah.
How? Well, you divide by this. You get x to the 5th is -1. The 5th root of -1 is -1. 10. What'd you get? -4. Do we all agree?
Yeah.
Wait. Oh, that's right. Now I get it.
And what'd you get for 11?
Plus or minus.
Plus or minus 10. Good.
Yes.
Again, the reason we have plus or minus 10 on the last one is because you have an even nth root. When you take an nth root that is even, it's plus minus. When you take an nth root that's odd, keep the sign of whatever the a value is. From here, it's basically section 7.1, page 404. Oh, I forgot what numbers they were.
Why would you take that? That's all I had.
14 through
Why would I take
40. And 54 to 66. Yep. We'll get that going for today. I'll put it up on the board because some of you guys don't like to carry books because they're heavy.